Hello, my name is Owen Burns, and I'm representing my group for our case study on relativity space and how they are advancing the rocket manufacturing industry. Here is a brief overview of our case study. We will cover the history and description of our chosen company, the traditional manufacturing process of rockets, the additive manufacturing process of rockets, and discuss the future of rocket manufacturing as a whole. The target company of our case study is a successful startup company known as Relativity Space. Relativity Space is a private aerospace manufacturer located in Los Angeles, California. The company was started in 2015 by Tim Ellis and Jordan Noon. Ellis and Noon met in college, and both ended up in the space business. Ellis went to Blue Origin and Noon went to SpaceX. Both were convinced that a strong investment in 3D metal printing would demonstrate its viability, agility, and short lead time. Higher-ups supported and encouraged their efforts, and they had some successes. But, as Jordan Noon said in an interview with SpaceQ, it became clear that the two larger companies were too committed to traditional supply chains, processes, and approaches. That's when they started Relativity Space. Noon and Ellis realized that in order to succeed, they needed to commit entirely to 3D printing rockets, and only a startup could be agile enough to risk it. Noon pointed out that it was tremendously different from traditional rocket manufacturing. Truly taking advantage of 3D printing in rockets requires both a revolutionary and an integrative approach, one that combined entirely new approaches to both 3D printing and rocketry. Using a vertically integrated technology platform, Relativity is at the forefront of an inevitable shift towards software-defined manufacturing. By fusing 3D printing, artificial intelligence, and autonomous robotics, this company is pioneering the factory of the future. Before we get into detail on how relativity space revolutionizes the rocket manufacturing industry, let's go over some basics on how rocket manufacturing typically is done. Rockets are traditionally manufactured with a series of very large and expensive machines that will form various rocket parts and panels, join them by welding, and eventually assemble them all together. This slide includes some of the large machines that are used during traditional rocket manufacturing that are not necessarily needed in 3D rocket manufacturing. By not requiring these machines, 3D rocket manufacturers save on facility space, cut down on manufacturing time, and most importantly, save countless amounts of money from not buying the machines, paying people to operate them, and saving on maintenance and energy costs. Additive manufacturing, also known as 3D printing of rockets, is done with metal, specifically through the selective laser melting process of additive manufacturing. A high power density laser is used to melt and fuse metallic powders together. It is an extremely hot process compared to plastic printing, achieving temperatures of over 2,500 degrees Fahrenheit. The repetitive heating and cooling of the printing process can create stresses, cracks, and voids within the metal body. Manufacturers need to perform internal inspections before the metals can be used for sensitive tasks. But interest in additive manufacturing continues as creators chase the dream of creating an infinite variety of on-demand, custom-made parts. The space sector has had some successes as well. Both Jeff Bezos' Blue Origin and Elon Musk's SpaceX use small-scale 3D printing to create some specialized parts. The Stargate is the 3D printer that manufactures their rockets. The world's largest 3D printer, it was entirely designed and built by Relativity Space and fills up a whole room in Relativity's factory in Los Angeles. It doesn't look like an advanced manufacturing facility. If anything, it just looks like a set of robot arms over a rotating base. One of these arms liquefies Relativity's proprietary aluminum-based metal alloy and deposits it one layer at a time on the spinning base. The other arms support the process, polishing the metal, removing imperfections on the surface, and inspecting the material to ensure that it doesn't have any of the cracks, stresses, and voids that have been an issue in 3D metal printing. It all happens without human intervention as well, having ingrained sensor and analytics-driven machine learning. Here's a clip provided by Relativity Space where the Stargate system builds a part for the Terran 1 engine. The additive manufacturing process is one that allows Relativity Space to design a rocket that is made from much fewer components. For instance, the dome, the tank walls, the stringers, and mounting brackets can all be integrated into a single component. This effectively reduces the number of joints and discontinuities on the tank and reduces risk in other areas of concern. One of the biggest advantages is with wide joints, where a typical dome would join into a tank wall. Relativity Space is able to continuously print and separate the joint in one single piece, rather than having to take a thick sheet of metal and machining it, rolling it, welding it, thermally cooling and expanding it. Relativity Space does it all in one single piece, and that really reduces the amount of waste material, as well as effectively removing all subtractive processes. All the material that's printed is used in the end. whereas typical manufacturing would waste 80 to 90% of the material. The need for floor space is significantly reduced, which allows for expansion of the launch vehicle size and components. Stargate is critical in the production of their 3D printed Terran 1 rocket. The Terran 1 is Relativity Space's signature product, an expendable launch vehicle under development that will consist of two stages. This rocket also has a nominal payload of 900 kilograms to low Earth orbit. Relativity boasts that their rocket is, quote, among the most cost-effective launchers in the world, end quote, at around 12 million US dollars, which is much lower than the cost of launching with a company like Blue Origin or SpaceX. This graph demonstrates the vast difference between the number of components of an average rocket compared to Relativity's Terran 1. By utilizing a minimalist approach, Relativity has decreased Terran 1's component count over 80 times. This simplifies supply chains while increasing overall system reliability. These are some brief stats on the Aeon 1 engine. This engine is made out of a proprietary 3D printed alloy. It's mostly 3D printed and assembled from fewer than 1,000 parts. It uses a gas generation engine cycle, liquid natural gas fuel, uses gas torch ignition, and produces about 25,400 pound-force of thrust. On the left graph, we see that the average lead time for other rocket engines is around 6 months. However, since Relativity's Aeon 1 engine was designed with an evolvable engine architecture along with 3D printed components, lead times for the Aeon 1 is only 2 weeks. In the right graph, we see that Relativity has drastically streamlined engine component count, which opens up possibilities for automated engine production. Here's a clip provided by Relativity Space where the Aeon 1 engine is being tested in the NASA E3 facility located in Mississippi. With interest in additive manufacturing growing in the rocket industry, as shown with Blue Origin and SpaceX 3D printing small components, it may soon be common practice. Rockets can be cranked out faster with less material, waste, and cost, all using automated, artificially intelligent 3D printers. Relativity Space is quoted in their mission statement that they, quote, believe in a future where interplanetary life fundamentally expands the possibilities for human experience. In realizing this audacious vision, our long-term goal is to upgrade humanity's industrial base on Earth and on Mars. End quote. Someday soon, the Stargate 3D printer could be a standard part of humanity's presence on Mars, fabricating parts, tools, vehicles, and maybe even housing. If Relativity Space is able to overcome the challenges and make metal 3D printing practical, the possibilities are endless on what the company could accomplish. Thank you for taking the time to listen, and this concludes our case study into the future of rocket manufacturing in Relativity Space.